Okay, this is the first question of the review materials for test 2. This question has, well, it was on the first test and it showed up again. Majority of students got better on this one, but still some of you are still struggling. So I want to go over this hopefully for one last time, and you will be able to understand what the notation it's about, and hopefully you can see what it means. Now, to really do well for this question, I always make this claim, which is that if you can do f of 3, for example, okay, if you can do f of 3, there is no way you don't know how to do this. These problems. It's really about how you look at the notation. The notation, it's of course more complicated than a number 3, but in terms of meaning, they have the same meaning. So when we say f of 3, okay, we will say, oh yeah, so this 3 right here is the new x value. So therefore, you would replace the x. Okay, so basically this is the function f, but now for the x value, it will become a number 3. So you would just go ahead and simplify it, and then you finish the problem, right? You would do 3 squared, it's 9, and then 9 minus 10, it's -1. So you get full credit on this one. So what I want to show you is that the following 3 problems on the left, they are no different. Okay, theoretically speaking, they are no different than f of 3. So f of g of x, well, g of x, this thing right here, is the new x value. F of 2x minus h is the new x value. F of, well, 2x plus 1 here is the new x value. Okay, 2x plus 1 is the new x value. So all the highlighted parts on the left, they are the new x values. And because of that reason, you will substitute these values into your x position. Okay, so I'm just going to put it on the sides for your reference. And what you can see here is that, well, we basically do the same thing. The function f, it's x squared minus 10. But in this case, what is the new x value? It's g of x. So you can put in g of x there, or you can put it what is really g of x. Well, the thing that it's really g of x, it's x plus 2. And because of the equal sign right here, you can now replace g of x with x plus 2. So this replacement can occur and can only occur because there is an equal sign telling us that, oh yeah, g of x is equal to x plus 2. So you are more than welcome to substitute. Okay, so whenever you substitute something, you must be able to justify. Okay, who gives you the power? What gives you the power to substitute? What gives you the power to write such notation? Okay, and because there's a 2 right here, if we do the FOIL, you would see that there'll be like terms forming. Now, I want to take a moment to make sure that everyone is aware of the common mistake or mistakes here. So what I've seen so far is that some of you, well, not a majority, but some number of you would make the following mistake. So x plus 2 squared, some of you still make the algebra 1 level mistake where some people think that this is the case. This happens because of an incomplete concept of square. So for those of you who still commit this mistake, I hope you know who you are, because if you know who you are, then you can fix it. The problem of this, the root cause of this error, it's probably because of of you memorizing something about the power which you were thinking about distributing, but then you did not quite recognize when you would do distribution, and you definitely did not recognize that this is not the situation that you will distribute. This is not the not the moment you would distribute. So what you should do is to really go back to the understanding of what the notation of square means. And I would say that you probably know what it means. Square, well, we learned that in what, elementary school? I mean, you must have seen it in middle school, and it means multiplying by itself. So the best way to understand this notation is to practice the verbalization of these notations. Square means multiplying by itself. So therefore, you have x plus 2 times x plus 2. That's x plus 2 squared. And then do not forget the minus 10. Now, I have students who did a fantastic job recognizing the need of foiling. So showing the x plus 2 times x plus 2. And because it took all of the attention away from the student, well, the student forgot to follow up with the minus 10, and that was a pity. Okay, could have avoided losing the credit, losing the points because of this carelessness, but it happens for a reason, because the x plus 2 square was taking all the attention away. So keep your scope wide, and look at the notations back and forth to make sure that you actually have the proper notation. So so if you do your foiling correctly, so you should have this, and then minus 10. And so we have x squared plus 4x minus 6. This is your final answer. Okay, this is your final answer. All right. So we basically do the same thing for the next two. So again, we are looking at function f. So we have 2x minus h squared minus 10. Now, another common mistake that I've seen here is that because of the 2x, because of the minus h, some of you are, well, were freaking out when you saw the h, when you saw the x, and you thought of something else, okay, because it was not a simple number. So your mind was like, hey, it looks different. You probably want to do something different. And this is not a special situation. We will do something different. This is just like f of 3 at the right upper corner. So you just put in the new x value. In this case is 2x minus h. So you can leave it like this, or you can expand it. Either way, it's fine. So you have this. All right. And I have a small number of students who would wrote a minus h squared instead of plus h squared. And I also had a small amount of students who forgot to put the square for h. Don't know why. Probably the attention span was being taken away by the earlier foiling process. So and then so somehow forgotten to do you have forgotten to do the h square as a result. So that is your final answer. Okay. And then the last one, same thing. Okay, 2x plus 1 squared minus 10. And again, if you do the FOIL for the parentheses, you would see that there should be a constant left behind. That means you will have some like terms to combine. So again, we just practice the definition of square. We just take what it's given there. We just take what it's on the paper. Okay, don't make it too complicated. 4x squared plus 4x plus 1 minus 10. And so you have 4x squared plus 4x minus 9. So that's really it. Okay, so I would say this problem, if you got this kind of problem wrong, it is mostly psychological, because got distracted when you saw the notation being somewhat different than a simple number. So your brain, your mind told you to do something different, which you actually don't need to. So just go ahead and follow the notation. The highlighted part is your new X value, so do not think anything otherwise. Yeah, I saw some students doing some strange things, such as they were thinking about something like this. That's not true. That's not true at all. Okay. So it's really down to the understanding of notation, which I have stressed since day one of the course. Okay, so keep watching. I'm going to post the video for question 2 right away.